Welcome to the shop. In today's video, I'm going to be making some more NQALHA parts. Each NQALHA requires 75 individual custom-made parts, and for a run of 10, that's going to mean 750 parts, so I better get going. In the previous two videos, when I started this project, I went through the entire detailed setup of how the machines were set up, how they were configured. If you're interested in seeing that, well, you can go back to the first two videos. As the series proceeds, I'm going to be doing less setup and just showing how the parts are made. There's no need in being overly repetitive. So I start out with my setup sheet, put on my safety glasses, which also are prescription so I can actually read things, and look, 8.86 by 2 by 1/4 inch aluminum extrusion. I use aluminum extrusion for almost every part of the NQALHA, almost every aluminum part that is. It's a very convenient way of buying material, using material, and actually the design of the machine was designed with extrusion in mind to make it easy, because cutting up plates on the table saw is a little bit more annoying. So 8.86. And of course, I always cut them a little bit long. I'd rather waste a fraction of an inch of material as opposed to having it be just a bit too short. So yeah, there we go. I've got a stop on the chop saw here, and yes, this is a metal cutting chop saw, slower speed than a wood cutting chop saw, with a specifically designed aluminum cutting blade. Using WD-40 as a cutting lubricant. So, gonna start off here. I have a complete set of tooling plates from previous production runs, and unless the parts are modified, the tooling plates are entirely usable and will be used. I also have all of my screws and spacers and all the other necessary fixturing to get the job done. This is a known design, a known tool path, trusted, worked perfectly last time it was used. I'm gonna put the tooling plate in place. This is the long part, and it's almost at the limit of length for what I can do with the vise setup. So, gonna set my zeros. The first operation is going to be to drill holes in the blank with 0 set on the top surface of the blank. Second operation, moving over here to the tooling plate, and it will cut the outside profile. And the third operation will be drilled over on the bridge port. So I've got two different work offsets, work offset 1, work offset 3, which is pretty much my standard work offset configuration that I use for almost everything. So let's get the The Tormach electronic tool setter works really nice, and it provides a good Z-axis reference, but it does have some rather odd quirks that drove me kind of crazy for a while. It turns out that the probing speed is going to end up being the last feed rate that you selected in the program. It's like the G code is modal, and so the probing speed is actually the last speed that you used. Well, if the last operation was a tapping operation, that sets the inches per minute to 0 because tapping is done in inches per revolution. And then if you try to do a Z-axis probe after a tapping operation without manually resetting the feed rate to the specific feed rate that the probing operation requires, the probing operation will fail in a very mysterious way. So this thing is, it's a minefield of quirks and workarounds, but you know, once you get it under control, the thing actually does work. So, as always, even though this is a known trusted program, I treat every program as a new program if it hasn't been run for a while. So, going to have my finger on the e-stop, carefully run in single block mode, and just to make sure, because it's so easy to make mistakes while doing this, especially while improvising a narration. So just wanted to make sure that the part was securely in place. And no, this is not correct. Yep. So that's a good lesson. That this part is too long. And I believe that if I tried doing it as it's inserted in the vise, yep, it wouldn't work. So much for faulty memory. The last time I did this production run was last year, I think. The setup sheet is wrong. The setup sheet says G54 for the first operation, and it's not. So the only way, and when I first put the blank in the vise, I was kind of looking at it and going, I don't know, that looks a little strange. So time to go edit the setup sheet. Just make a mark with the Sharpie to remind me that the setup sheet is wrong. So go over here to the comment on the toolpath, and it's correct. Work offset 3, top of part. So pay attention, cross-check, double-check. Single block. Finger on the e-stop. Get my coolant nozzles back in place. Observe that the pre-feed height, which is inserted by the toolpath program, the rapid to pre-feed height is correct. Rapid to feed height is correct. No, it's not. It looked correct to the eyeball. Anybody out in YouTube land want to tell me what my mistake was? Z0 was set at the top of the tooling plate. The material, the tooling plate is 3/8. The material, the blank, is 1/4. So Z offset was incorrectly set. The quick eyeball sanity check looked reasonable because it was only 1/8 off, but it was not correct. So let's try that one again. Pre-feed correct, feed correct. I should probably optimize this tool path. It looks a little wasteful of time, but it actually does look correct. And yes, that is quite a lot of stick out, but it makes good parts. So it's not, other than looking dicey, it actually produces reasonable parts. So pre-feed height looks correct, feed height looks correct. These holes are just to make the part a little bit lighter, tiny little bit of decoration. This is going to be the roughing cutter. Pre-feed correct, feed correct. This is the aluminum shredder roughing cutter from Lakeshore Carbide that is cutting through now. Going over to a 1024 tap here, and everything is looking correct, but I don't know, memory is so weird. I remember this as being a successful tool path, but the amount of flex and stick out here is kind of bothering me. And so I may go ahead and revisit my notes and re-zero using a spacer so that I get the right side clamped on the right vise. I'm probably going to go ahead and revisit my notes because it appears that the setup sheet doesn't say anything about a spacer, and I just don't like this stick out. And okay, note for all of you trying to learn CNC machining. Memory can be weird and unreliable. This is also a bit of a warning to me to make sure my setup sheets are correct. After a quick trip to the Bridgeport, I have now constructed a spacer so that the part is supported on both sides, and I'm going to reset my zero position and then right on my setup sheet, so the next time I do this, this is actually a pretty important part of the process here, that little bit by little bit, I'm perfecting everything. I'm perfecting the tool path, I'm perfecting improving the cycle time, and improving the documentation, because This was, I can't believe that the last time that I made it with that amount of stick out and that amount of instability. I'm sure that I used a spacer, but I didn't write it down on the setup sheet, and I didn't write it down in the G-code. So now that mistake has been corrected. Fortunately, as mistakes go, it was a kind of a nothing. I believe that this first part will not be trash. I believe it will be usable, but I definitely inspect it for proper dimension before making the final assessment. (5140 RPM, 10 inches per minute, fast peck cycle, 60 thousandths per peck. And the reason that the tool path is so insane is that there are two types of holes for two different purposes, but they're being drilled with the same drill. The 1032 tap drill is the same size as the 832 clearance drill for a tight fit. And so the two different tool paths, one is for a tapped hole, one is for a drilled hole, end up being slightly insane and wasteful. And I'm not sure it's worth going back in the CAD room to attempt to optimize that any further. But that's why the tool path appeared to be jumping all over the place. This is, let me look over here, 2500 RPM, 10 inches per minute, fast peck cycle with 70 thousandths per peck. And it looks like the tool is staying clean. Spindle horsepower is well within reason. The chips are coming off nicely. The main thing I try to do when creating tool path for drill operations is to make sure that I don't end up with a wadded up rat nest ball of chips. And oftentimes we're doing let me interrupt my thought here, doing a ramp in as opposed to a plunge here. Got a tiny bit of chatter on the roughing cut, but the finishing cut will clean it up very nicely. The feed and speed for a drilling operation, if you use too slow of a feed, the chips come out thinner. And thin chips are more flexible, they don't break as well, and they tend to form a rat nest. So I use a fairly aggressive feed of 10 inches per minute together with a fairly slow rotation speed. This produces thicker chips, thicker, shorter chips, and the thick, short chips tend to break a little better and not form a rat nest. So using Tap Magic tapping fluid for my power tapping using the compression tension tapping head. This particular Tormach does not support rigid tapping. It doesn't have an encoder on the spindle, but I can do machine tapping using the compression tension head, which has, it's kind of got it's spring loaded, so it's got a little bit of tolerance because the machine doesn't really understand. It's unable to measure precise spindle speed, and so it does its best. The spindle was calibrated with a tachometer when the machine was set up, and so the machine does its best to figure out what amount of feed to use per rotation, but it's not perfect, and the spring in the head takes up a little bit of that imperfection and allows holes to be tapped very nicely. So I'm going to do a quick sanity check here. The milled hole in this part is where the bearing fits in, and the fit here is not a press fit, but it's a loose, semi-loose, semi-tight, kind of in the middle fit. It's perfect, exactly the way I like it. But this kind of a slightly loose, maybe a thousandth loose fit works really well with high temperature Loctite retaining compound, which is what I use to hold the bearings in place. And over all of the NQALHAs that have been made so far, I've never had a bearing pull out. The high temp, even though the bearing is on the end of the machine that gets hot, I've never had a failure of the bearing, never had a bearing pull out due to overheating and the failure of the Loctite. So it appears that the design and the material works really well. So I'm going to go into production now and do the next 8 parts. Don't need to do that on camera. And then I'll come back and turn the cameras back on for the second and third operation. The first operation has been completed successfully. I've got 10 parts here ready to go, looking good. So now I'm going to take my tooling plate and put it in the same position so it can be gripped by both vices. And I'm going to reset my 0 point. And actually, I kind of need to make sure that spacer doesn't get caught in the cutter. There we go. Tooling plate is in place. Going to reset my 0. My X and Y should be correct because I'm using the same reference. Even after all the thousands of parts that I've made, I still don't remember which direction to twist the knob. So go over here and remember to manually set the feed rate back to 25 inches per minute, because the probing operation won't work after a tapping operation. When I reported this to Tormach, at first they didn't know what to think of it. I told them, hey, probing isn't working. It isn't working at all. They couldn't figure it out. They said, start from scratch, reinstall the entire operating program. Well, it turns out that the program has a modal memory, and so it remembers the previous G-code setup, even on a power on reset. So it was continuing to remember that the last operation performed was a tapping operation, and it just drove me crazy for a long time until I figured it out. Then when I finally figured it out, and talked to Tormach technical support, they said, oh yeah, you need to set the feed to 25 before probing. I don't know. So, go over here to the second operation, looking at the screen to do a little quick sanity check to verify, yep, it looks reasonable. Looking at my notes that I have notes embedded in the G-code that tell me what I need to remember, and little bit by little bit they get better as I realize, oop, forgot that one. So let's do a dry run. Once again, this is a known trusted program, but I treat all programs as new programs if I haven't run them for a long time. Pre-feed looks correct. Feed looks correct. Profile looks correct. Okay. I'm confident. Sanity check passes. Kind of a nice, convenient thing that just happens to work out. Actually, that comment is not relevant for this part, so ignore that comment. It will be relevant to other parts. I'm using the holes in the part to screw it down to the tooling plate. And I typically use the tightest diameter that I can. If you look in a standard chart, it will recommend using larger clearance holes for screws. I use the tightest clearance hole that I can get away with, that the screw fits in nicely, because I'm doing CNC machining. I've got good tolerance, it's under control. I don't like sloppy fits, and a side effect of this is that I can confidently use the holes in the part for locating and get my location within a couple of thousandths. Of course, the perimeter of this piece, it doesn't matter, at plus or minus 5 is fine, but I bet it's actually coming out better than that because of the tight fit of the mounting screws to the clearance holes. So, I'm going to be using the aluminum shredder from Lakeshore Carbide. It's a roughing cutter that has serrated flutes and makes a very, very fine chip that evacuates very nicely. A lot of the cuts that I do when I cut my parts, a lot of the cuts that I do are basically cutting long slots. And long slots can be really troublesome. Long slots can really get you in trouble if you don't have proper chip evacuation. I've had problems in the past where I've broken off a cutter because I didn't have enough chip evacuation. The aluminum shredder makes the very small chips, and they evacuate very well with flood cooling. And by the way, I'm using Trim Microsol 600 semi-synthetic coolant. A lot of, when I look at the specifications for coolant, and boy is it ever confusing, coolant information is very confusing to read and understand, and there's so many different variations of it. So stop talking, start thinking, pay attention. Pre-feed height is correct. feed height is correct. There are so many different specifications for coolant, and many coolant manufacturers recommend using a soluble oil for aluminum. Soluble oil has a problem of going rancid, and especially in my shop, where sometimes the machine sits unused for many months, I don't want to have to worry about my cutting oil going rancid. So I found this material, which claims in their specification to be suitable for aluminum, and in fact it is. Works really well. So profile has been completed. Surface finish looks absolutely beautiful. I love the surface finish that I'm getting. I probably could get away with not using a finish pass and just cutting the entire profile with the straight flute 3/8 solid carbide, but for a few extra seconds, doing it with a roughing pass and finishing pass prolongs the useful life of my finishing cutter, because it's not getting beat up and abused. And I just love the surface finish that it produces. So using a cordless screw gun here at the low torque setting, because I don't need a lot of torque for an 832, and I don't want the head of the socket screw to ding up my workpiece. So, third operation, I go over to the bridge port, and this is just a single hole. The third operation is a single hole. I'm putting the perpendicular hole in the edge of the part. This hole functions as an adjustment screw for adjusting the NQALHA head position to be perpendicular. Okay. And I'm going to be tapping it with my hand drill. This I have a pretty good eye for perpendicular, and this hole does not need to be tapped to the highest level of precision. If it's a little bit off, it don't matter. Holes that I care about, that really have to, that serve precise and important alignment functions, those holes I machine tap or manually tap with a tapping guide. But once again, my overall philosophy as a machinist is use the appropriate amount of precision, the appropriate amount of care for the part being made. And at the same time, of course, I always like to make things as precise as I can, so it's a kind of a balance, a kind of a competing balance going on between the two philosophies. So the machining operation is now complete, and the parts look really, really nice. So now I'm going to go over here to my El Cheapo Harbor Freight vibratory finisher. And yes, I wish I had a nicer one, I wish I had a bigger one, and maybe someday. But for today, this little guy actually does work. It's not a really good one, but it kind of does work. Used it for a while, so I'm gonna kind of rinse it out. I'm using plastic, well, you can see there in the video, little cone-shaped plastic abrasive pellets that the catalog says are really good for aluminum, and they've done a really good job for me. So, just let a little more of the dirty water drain out. It's important to have some water in the vibratory finisher, but there's a balance between, balance like in so many things, where I have just the right amount. These parts are about the longest part that I can possibly get into the finisher, but it does work. And it ends up producing a nice result. So that completes part number 102, and thank you for watching.